Hey everyone, in this video we're going to talk about section 3A.3, which is going to be about reflections. So a reflection is another one of our transformations that we're going to study. A transformation is going to be a motion that flips a figure over a line. That line's going to be called a line of reflection. So I kind of like to think about reflections as like a mirror, right? When you look in the mirror, you see basically the same image back at yourself, just it's kind of flipped a little bit. So if I'm looking at these L shapes right here, these L shapes are reflected. And so we can have this line of reflection that's going to be in the direct center between the two. So for instance, since my L was 2 units away from one side of the line of reflection, it's going to be 2 units away from the other side. So those distances are going to be the same across from our line of reflection. We do have several coordinate rules for our reflections. So first is a reflection over the x-axis. So if I'm looking at I'm going to draw a little coordinate plane up here. If I'm looking at a point here and I reflect it over this x-axis, I know that my x-coordinate is going to stay the same, but my y-coordinate is basically going to change sign. So if I was at a positive 3 up here on my y, reflecting it over the x-coordinate, I'm going to be at a negative 3. So our coordinate rule reflects, get it? It reflects that, that property. So our coordinate rules are always going to start with an AB. That's the original coordinate. And then when I have a negative b here, that negative b basically just means that my y-coordinate changes sign. So it doesn't necessarily mean that your y-coordinate has to be negative, it just means that it's going to flip sign. So if it was already a negative, it's going to become a positive. Okay. If we reflect over the y-axis, I'm going to draw myself another little picture up here. Okay, let's say that I have this point up here. Well, if I reflect over that y-axis, my point is going to end up over here. And so in this case, it's going to have the same y-coordinate, but now it's our x-coordinates that are kind of changing. So if this had been at an x-coordinate of 4 on one side, well, it's going to be at negative 4 on the other because we're going to have that same distance away from the y-axis. So our coordinate rule starts at AB, and then it says we're going to end up at negative AB. So in this case, our x-coordinate changes sign. Okay. And then we have a reflection over the line y equals x. So what do we know about the line y equals x? Well, I know that y equals x, we have a slope of 1, and then we have a y-intercept of 0. So our line of reflection looks like this. Okay, and when we reflect over the line y equals x, let's say that we start off with a point right here, it's going to end up reflecting to the point, if we start at AB, it's going to reflect to the point BA. So this tells me here that our x and our y coordinates are going to flip positions. So we have a reflection over the x-axis, we have a reflection over the y-axis, and then we have a reflection over the line y equals x. Now, here's the deal. We're also going to have reflections over other types of lines, maybe other horizontal and vertical lines. However, these are the only ones that are going to have some distinct coordinate rules. I should have mentioned, go ahead and write the date up here, just so that way you can look back and you know what date you did this at. Okay, we're going to go on to number 1. So we're going to sketch the line of reflection on each diagram between the pre-image and the image, and then we're going to state the line of reflection or the equation of the line of reflection. Okay, so remember, our pre-image is going to be our original shape, and then our image is going to be the one that's where it's transformed to. So my image is going to be the one with the primes, and my pre-image is going to be the one with no primes. So we need to try to figure out, okay, where's the line that it was flipped over? And so to look at this, I'm just going to look for, okay, well, what's the line that's directly in between, or like the middle between two different points? So if I'm looking at R and R prime, I'm thinking that this is the line that's directly in between those 2 points. Okay, or I could look at like W and W prime. This has a distance of 2, and this has a distance of 2. Okay, so it's directly in between. Okay, so let's think. What was this line that we reflected over? Well, that is the x-axis, okay, and so that's one name of it. However, if we have to give it an equation name, what would that equation be? Well, okay, let's think. It is a horizontal line. Okay, and so horizontal lines have an equation that starts with y equals. So I think this is going to be y equals 0. Okay, so that's our equation. If we look at the second one over here, let's go ahead and let's find this line that these two shapes are reflected over. So again, pick 2 points. I might pick r and r prime. Let's find that point that's in between, right there. So this is going to be our line of reflection. Okay, so now we need to write the equation of this. It's not the x-axis, it's not the y-axis. We actually have to write an equation for it. I see that this is a vertical line. And so vertical lines are going to have the equation starting with x equals. So I think that this is going to be x equals, let's see, -1, -2, -3. This is x equals -3. All right, looking at this next one, okay, again, hopefully we're starting to get the hang of it a little bit. We're looking for the line that's directly in between these two shapes. If I'm looking at P prime and P, this is the point that's directly in between. So here's going to be my line of reflection. So that is for sure the x-axis. Wow, just kidding, that's the y-axis. Okay, that's the y-axis. And so if I write the equation of it, it's a vertical line. And so I think that's going to be x equals 0. Okay. We have one more here. So, well, in this case, I don't see like a... I can tell they're kind of reflected, but they're kind of reflected in a weird way, right? So I have this point u here. I have this point u prime. So where's that point that's directly in between them? I'm thinking it's this point right here. Okay. If I go, and let's try to find maybe another couple of points. So like here's h prime. Where's the point that's directly in between them? Well, I could count my slope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so down 2.5. 1, 2. Right here. Okay. So I have my 2 points here. I can definitely tell that this is not going to be a horizontal line or a vertical line. So since we found 2 points that are in between them, let's just go ahead and connect those points. Okay, so now it's kind of clear to me where this is going. I see that this line is diagonal. It has a y-intercept of 0. And then if I'm looking at the slope of this line, well, I can tell that the slope is up 1 over 1. So we have a slope of 1. So our equation is y equals 1x plus 0, or that's just y equals x. So that was like that rule that we were talking about up here. Okay, so we've seen a little bit of practice with finding, identifying some lines of equation, or some lines of reflection and writing the equations. Let's actually go ahead and do some where we have to find the lines of reflection or our image points ourselves. Okay, so in this case, we have this triangle ABC, and it's graphed here. We're going to determine the coordinates of A prime, B prime, and C prime after each reflection. Okay, so first we are going to reflect across the y-axis, okay? So buckle in, we're going to have kind of a lot going on here. Our y-axis is this axis right here. So if I want to reflect across the y-axis, I can go ahead and I can count my points, and I just have to count to the line of reflection, and then I have to count to the other side. So for instance, A is 1, 2 away from the y-axis, so I'm going to go 1, 2 on the other side. So this is going to be my point A prime. Okay, B is 1, 2, 3, 4, 5, 6 units away, so it's going to be 1, 2, 3, 4, 5, 6 units away on the other side. Okay, same thing with C. C is 1, 2, 3, 4, 5, 6, 7 units away. So 1, 2, 3, 4, 5, 6, 7 units away is C prime. And then with this is a triangle, so let's go ahead and we're going to connect our vertices together. Okay, so that was reflecting over the y-axis. Let's go ahead and list out where our coordinate points are. So A prime ended up at -2, 4. B prime ended up at -6, 5. And C prime ended up at -7, 1. Okay, so that was our reflection over the y-axis. We're going to look at another one now. So now we're going to reflect across the x-axis. So one thing that we could do is we could identify, okay, here is our x-axis, and so then we could count and reflect our shape over. Let's think about another way that we could do this, okay? We have these coordinate rules up here. So let's go ahead and try to use some of our coordinate rules because we don't necessarily need a graph with this. We kind of have this predictable pattern that's going to happen with our coordinate points. So my coordinate rule says that I'm going to take a point, AB, and when I reflect it across the x-axis, I know my x-coordinate is going to stay exactly the same, but my y-coordinate is going to change sign. So that's what we're going to look at, okay? So for this, I need to figure out where each coordinate point of A, B, and C are. So my point A is initially at 2, 4. So if I'm thinking about where A prime ends up, I know that A prime, my x-coordinate is going to stay exactly the same because it's just an A, okay? And then my y-coordinate of 4, well, I'm going to change the sign on it. So that's going to end up at -4. So my coordinate, and you don't have to graph it, but I'm just going to graph it, would end up right here. And that looks pretty reflected to me. We're going to do the same thing with B now. So, okay, our coordinate B is at 6, 5. So if I reflect across the x-axis, I know that my x-coordinate is going to stay the same at 6, but my y-coordinate is going to change sign, so that'll turn to -5. Same thing with C. C is at 7, 1. So C prime, when I reflect across the x-axis, I'll be at 7, and then my y-coordinate will be -1. Next, we're going to reflect across the line y equals -1. Okay, so y equals -1 is a horizontal line. So finding where that is, here's y equals -1. Okay, we haven't seen a line like this quite yet. And so when we are reflecting across a horizontal or vertical line that's not the x-axis, that's not the y-axis, that's not the line y equals x, we do have to graph this and we have to count. Okay, so there is no coordinate rule for this one. So reflecting across this line, change colors. Okay, let's do this in purple. We're going to count to that line, and then we're just going to keep counting. So, for instance, A is 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 is going to be down here. So A prime ends up at 2, -6. Okay, B prime is here. So it's 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5. Oop, we're going to be off the graph a little, but we'll be down there. It looks like we're going to be at 6, and that would be at -7. And then C prime is 1, 2 away, so 1, 2 away. Here's C prime. And C prime is at 7, -3. Okay. Our last one that we have is going to be reflect across the line x equals 3. X equals 3 is a vertical line. And so, there's a lot going on in my graph here. That's okay. X equals 3 is going to be this line right here. And so, okay, I see that it cuts into the middle of my shape. That's okay, okay? That means that we might just have to reflect, and our two shapes are just going to be overlapping. So if I'm looking at A, for instance, and I'm reflecting over it, I see that it's 1 away from our line of reflection, so A prime will be right here. So A prime is at 4, 4. Okay, B is 1, 2, 3 away from that line of reflection, so 1, 2, 3. B prime is going to be at 0, 5. Okay, and then C prime is 1, 2, 3, 4 away, 1, 2, 3, 4 in the other direction. C prime is at -1, 1. And so our shape A prime, B prime, C prime is right here. Okay, that was a lot going on. So there's going to be some times where maybe doing the reflections on the graph is the best way to do it, and that's great. There's going to be some other times where wanting to use the coordinate rule is going to be good as well, okay? So let's go ahead. We're going to flip over our page. Oop, I had that doubled by accident. There we go. Okay. We're going to look at our page over here. We'll come back to number 6 later, but I want to finish off this video with question number 7, okay? So question number 7 says to graph triangle DEF with the vertices D, E, and F, and we're going to graph its image after performing 2 transformations, okay? So whenever we do 2 transformations, this is going to be called a composite transformation, and we're going to label these vertices as D double prime, E double prime, and F double prime. So whenever we're doing 2 or more transformations, we're always going to do them in an order, okay? So the first one that's listed is going to be transformation number 1, and then the second one that we do is transformation number 2. So doing transformation number 1, I'm just going to write out my points. D is at -3, -4. E is at 1, -3. And F is at 0, 1. Those are our original points. So first, let's go ahead and we're going to do our reflection. Okay, and I see that that's my reflection in the x-axis, and so I could use my graph. I personally prefer to use my rules. So I'm going to start with the point AB, and then I know when I reflect across the x-axis, okay, it's just going to change the sign of my y-coordinate. So I'm going to be at A, -B. So if I do this to all of my points, D, E, and F, well, when I make one transformation, I'm going to put a little prime next to it. Okay, so here we go. So D is at -3, -4. Okay, my x-coordinate will stay the same, but I know that my y-coordinate is going to change sign. So since it was initially a -4, it's now going to become a +4. Okay, E prime, my x-coordinate will stay the same. My y-coordinate is going to change sign, so that'll be a +3. And then F prime, okay, my x-coordinate will stay the same, that's 0. My y-coordinate is at 1. It's going to change sign. So since it was positive, it'll turn negative. Okay, so those are my points after just the reflection. Now what we're going to do is we're going to do the translation from these points. So I'm going to use the points D prime, E prime, and F prime to do my transformations to those. So since this is going to be my second transformation, I'm going to put a double prime now to show that this is the second place it's going to move. Okay, and I'm going to use these points here. So my translation is x minus 2, y plus 6. Excuse me. So I know that we are going left 2 and then up 6. So that means to each of these coordinate points, I'm going to subtract 2 from my x-coordinates, and then I'm going to add 6 to my y-coordinates. Okay, so let's see. So -3 minus 2 is going to give me -5, and then 4 plus 6 is going to give me 10. So D prime is at -5, 10. E double prime, excuse me, is going to be, so 1 minus 2 is going to be at -1, and then 3 plus 6 is going to be 9. And then F double prime, okay, 0 minus 2 is going to be at -2. And then -1 plus 6 will be at +5. Okay, so there's where my shape ends up with. So we did 2 different transformations to this. We did that reflection, and then we ended up doing the translation. And the thing that we have to remember is you're doing the second transformation to your pre-transform, or to your already transformed points, okay? So you do one transformation and then the other. That's all we're going to do in this video for right now. So go ahead, make sure that you finish up your notes, take pictures and submit on Canvas, and then start your practice problems, and I will see you all later.